Welcome to the third part of our series, Exploring GRAFIS CAD. In the last video, we created a hooded jacket. We will now lay out the style in the GRAFIS marker making program and prepare it for output to a plotter. We will also have a look at various tools and special application options. I'll start directly in the GRAFIS marker and open the style of the jacket. You will see all the production parts in the sizes selected in the size list of the style. The marker shall later be output as a plot file. However, before the parts can be laid out, a few settings need to be made. I select the fabric type for the production parts and specify the paper width of my plotter. If you are preparing the file for a cutter, you should enter the material width accordingly. In the selection of spreading type and bundle direction, different production requirements can be accommodated. The next window lists all the production parts to be laid out. Here you can make specific settings for individual parts. For the production part of the hood, I'll activate various permitted transformations. This allows the part to be rotated freely on the material afterwards. However, this example is for illustrative purposes only. Which transformations you use in production will of course depend on your individual requirements. In the next window, the sizes to be laid out and their quantities are specified. I would like to plot sizes S and L once each. In addition to setting the bundle direction in the material dialog, you can also adjust the orientation here. Furthermore, step lays can be defined. Next, we move on to the layout view. The storage box at the top contains all the production parts in the two selected sizes. In the prelay area below, these can be rotated or sorted. The production parts are then placed onto the actual material area. Just as in the construction program, there is a toolbar on the right-hand side. The upper section contains functions for transforming the production parts. This allows parts to be mirrored or rotated. The tool groups below contain various options for placing or removing production parts. For example, entire bundles or equal pieces can be returned in this way. The status bar displays the layout length, layout efficiency, consumption per bundle, and further information. As mentioned, I would like to export the layout as a plot file. To do this, I set the output to HPGL2. Exporting as an ISO file for a cutter or as a PDF is also possible. If, for example, the marker layout is to be exported as a template, the scale may be adjusted to match the PDF page size. In the further plotting settings, annotations for the marker or part-specific annotations can be configured. Additionally, individual elements can be displayed or hidden as required. Now I click on Plot, and the marker for the jacket is then available as a finished plot file. The GRAFIS Autonester generates markers with optimized fabric usage. The program processes nesting jobs automatically in the background. When I send the style of the hooded jacket to the Autonester, I will receive a marker with optimized fabric usage after a predefined time. Next, let's take a look at some of the other features of the GRAFIS marker. The tool Create Fusing Block does exactly that. The contour can either be created as a rectangle or follow the shape of the production parts. In the Fabric dialog box, anchor lines can be defined for situations where the length is limited by the paper size or the cutter. Possible warp and weft shrinkage values can also be specified in this menu. The settings can also be configured individually for each piece. If there are fault areas in the fabric, they can be marked locally or as strips within the material. These areas are then automatically omitted during layout. If fabric needs to be rejoined during layout, suitable areas can be marked using the Overlap Areas function. The table sorts the potential areas according to the length of their overlap. With the Alternative Parts function, various groups of production parts can be defined where only one variant is laid out each. In this way, a continuous waistband could be automatically split into two parts. For instance, if the material width is insufficient for larger sizes. If the marker is created using the Autonester, the appropriate alternative group can be determined either by efficiency or by material width. When production parts need to be laid out in a pattern repeat, matching points between parts can be set in the relevant menu. It is also possible to distinguish between a symmetrical or continuous look for mirrored parts, and to position them at specific placement points on the fabric. Images can also be loaded into the background of the material. In this way, marker templates can be used or special fabrics can be matched to the production parts, for example leather hides or truck tarpaulins. It is also possible to preview logos or match digital prints to production parts. For orders involving large quantities and complex parameters, the GRAFIS CAD order planner is the right tool. The software supports you in production planning. Ideally, this is done in conjunction with a merchandise management system. It thus simplifies the planning, creation, and generation of markers and cutting stacks. This brings us to the end of the third part of our series, exploring GRAFIS CAD. In this video, you have learned about the GRAFIS marker making and seen how quickly a style can be laid out and plotted. For creating markers with optimized material usage, the Autonester is your best option. We also looked at a selection of tools and special functions that cover a wide range of production requirements. Thank you for your interest and for staying with us until the end. Feel free to visit our website for news and further information, or visit the GRAFIS Academy to learn more about our extensive training opportunities.